Alright, in this video I want to take a look at the u substitution as it pertains to exponential functions. There's really no difference than any other function. It's just that people have difficulty seeing what the inside is, right? When you're doing a u substitution, the u is what's inside the parentheses, right? And then the derivative of u has to be multiplied out there somewhere else. The issue here is that we typically don't write exponentials with parentheses. So let's go back to Calc 1. So remember when we were doing derivatives? Excuse me. Remember when we were doing derivatives? If I had a function like e to the 3x and I took the derivative, there's a chain rule that applies here. The basic rule for exponential derivatives is the derivative of e to the x is e to the x. But this isn't e to the x. This is e to the something else. This is e to the 3x. So the stuff in parentheses here is the 3x, but we generally don't write it with parentheses around it. This is when you're doing the chain rule, there's the inside function and the outside function, right? The chain rule says take the derivative of the outside, leaving the inside alone, and then multiply by the derivative of the inside. Well, with an exponential case, the derivative of e to the x is just e to the x. So you just leave that alone. You get the e to the 3x left alone. But then you got to multiply by the derivative of the inside. And the derivative of the inside here is the derivative of the 3x, and that is 3. Hence, the 3 comes out in front. Now, when we're working this the other way, when we're doing antiderivatives or integrals, for instance here, if there's something inside, you're always looking for those u substitutions. This is not just the integral of e to the x. This is the integral of e to the 3x. So there's, in parentheses, there's a 3x. Except we don't see it in parentheses because the parentheses aren't usually drawn. Sometimes they are, but sometimes they're not. There is a u substitution here with u equals 3x, and so then du is 3 dx, and dx then is du divided by 3. So I substitute du divided by 3 for x, and I substitute u as 3x, and then I get it as 1/3 e to the u du, and then the 1/3 comes out, and the integral of e to the u is e to the u plus a constant. And so I end up with 1/3 e to the u plus a constant, right? Which, substituting back in, u is e to the 3x. So the integral of e to the 3x is 1/3 e to the 3x plus a constant, right? There's a u substitution in there. This may seem really simple to some of you, because it's just like, well, you're just doing a u substitution like we were doing in the last section. It's like, yes, I am. I'm just pointing out that sometimes it's a little trickier to see with exponentials because you don't see the stuff in parentheses as being inside. Right. Here's another example. So we'll bring it right up to the top here so you can see the whole thing. Sine x cosine x e to the sine squared x dx, do the integral of that. Okay. Now, I am seeing that exponent that's not just an e to the x, it's an e to something else. So I'm letting u be that whole exponent, sine squared x. The derivative then is, there's a chain rule here, taking this derivative because it's 2 sine x to the 1 power times the derivative of sine x, which is cosine x. So I have the sine x cos x dx, I don't have the 2. So the sine x cosine x dx is du divided by 2, hence the half that's going to show up in there. The sine x cos x dx all just turns into, well, it turns into the du over 2. And then the e to the u here is because that's e to the sine squared x, and sine squared x is equal to u. So I've turned this into just an integral of e to the u du, which is e to the u plus a constant. And there's a half out in front. That should be an e to the u. That looks better. The integral of e to the u is e to the u, not e to the 2. I don't know where that 2 came from, but anyway, there's e to the u plus c. Substituting back in, u was sine squared x. Okay. There's really nothing different here. It's just a matter of, with exponential functions, I think it takes a little more practice of just recognizing the inside and the outside function and how that works. Okay. Anyway, there you go. U substitutions with exponentials.